what is hiding beneath the dark sediment-filled water that has been sealed off for an entire century? The moment drill bits pierced through the concrete of a 100-year-old dam, biological radar immediately went to red alert. The signal coming back was not from just a few weakened individuals, but from 400 wild salmon clustered at explosive density within every 100 square meters. They rose up from oxygen-starved mud, where every living thing should have been wiped out back in the 1920s. Nature had built a perfect survival trap of its own, and outsmarted the scientific world for a full 100 years. How did one species manage to turn the entire game around after humans pushed it to the brink? The cruelest secret of this river is about to be revealed. Before the 1920s, Hiitolanjoki was a gigantic life-pumping machine of nature. The river carried a vertical drop of 18 meters, compressed into a chain of violent rapids that tore through every obstacle on the way to Lake Ladoga. Ever since the last ice age ended, this furious current had been the exclusive domain of Atlantic salmon living entirely in freshwater. Unlike salmon that migrate out to the ocean, the salmon population here carried a completely isolated genetic line. They completed their entire life cycle in freshwater, having undergone thousands of years of evolution to match the exact temperature, current, and oxygen concentration of this river basin alone. They were a biological legacy that could not be copied and could not be replaced through breeding or stocking from somewhere else. But by the 1920s, humans decided to intervene. 3 massive hydroelectric dams were poured in concrete and blocked the river for the hunger of industrialization. Instantly, the river's natural 18-meter drop was flattened into a series of silent reservoir steps. It was an ecological disaster calculated in advance. Once the current was blocked, water temperature surged and dissolved oxygen collapsed. Layers of bottom mud quickly built up, completely burying the cold gravel beds where female salmon laid their eggs. Migration routes were cut into pieces. Millions of salmon were trapped inside a suffocating system. The region's last freshwater salmon population was pushed into a decline that approached extinction for 100 years. Meanwhile, the electricity produced by those 3 dams became worthless. As the national grid modernized, the 3 dams turned into obsolete machines, generating only a tiny amount of power while forcing an entire ecosystem to pay for it with extinction. Collapse was closing in, but what made authorities abandon the usual solution and choose the most radical path instead? Normally, when facing the decline of migratory fish, humans use a common technical intervention building fish ladders or ecological bypass channels. This is considered the perfect way to keep the hydroelectric dam while also preserving nature. However, the latest data from ecologists points to a brutal truth: fish ladders are an ecological illusion for many freshwater species. According to aquatic biology studies across North America and Europe, even the most modern bypass systems fail at rates as high as 50% to 70% for fish with complex migratory behavior. For freshwater Atlantic salmon, a species that must move back and forth repeatedly during its life between spawning grounds in the rapids and feeding areas in the lake, merely getting past a dam in one direction is an irreversible path toward collapse. The narrow passage of a fish ladder also turns it into an ideal ambush point for predators. Recognizing the failure of half-measure interventions, a bold and unprecedented decision was made. The government bought back all 3 hydroelectric dams from the private energy company. The sole purpose written into the agreement was not restoration, not upgrading, but the permanent removal of the dams from the map. But tearing down a 100-year-old barrier is not as simple as using explosives. If done wrong, humans would unleash a disaster that would destroy the entire river habitat with their own hands. The removal of a dam is a high-risk surgical operation. The biggest problem does not lie in the concrete, but in what is hidden beneath the reservoirs. Through 100 years of stillness, tens of thousands of tons of sediment, fine mud, agricultural heavy metals, and rotting organic matter had accumulated behind the dam wall. If the dam were broken open suddenly, a flood of sediment would wipe out everything downstream. Those fine mud particles would cling to fish gills and cause mass suffocation, permanently bury spawning gravel beds, and exterminate all bottom-dwelling invertebrates. In the year 2012, during the removal of the Elwha Dam in the United States, the largest dam removal project in history, more than 20 million tons of sediment were released downstream, creating a murky plume of suspended material that killed off riverbed vegetation for many months before nature could adapt. To avoid a new ecological tragedy, the engineering team had to apply a multi-stage demolition process. They drilled small release openings to lower the reservoir level centimeter by centimeter, controlling the movement of sediment with extreme care. Heavy machinery stripped away the concrete layer by layer, while sensor systems continuously measured water quality and turbidity in real time. The moment the final barrier was removed, the river answered immediately. Water pressure that had been suppressed for a full century surged across newly exposed bedrock. The current automatically tore through the mud layers, sorted gravel and stone again, created swirling channels and complex hydraulic architecture. The function of a wild river was reactivated almost instantly. But the most extraordinary thing was still waiting ahead. A biological landing so astonishing that no scientist had dared to put it into a prediction report. What stunned the scientific community most was not the recovery of the current, but the speed at which the salmon reclaimed their territory. Under the usual rules of ecological restoration projects, when a habitat is rebuilt, humans must intervene by releasing millions of hatchery fish to re-establish the population. That process takes decades. But at Hiitolanjoki, the researchers did not release a single fish. The salmon appeared on their own. Throughout 100 years of captivity between concrete walls, a small number of salmon still held on in scattered patches of water, preserving their original genetic line through dozens of generations. By forcing themselves to survive through the harshest genetic bottleneck imaginable, they had sharpened their survival instinct to the extreme. The moment the water began to flow again, that inherited instinct awakened. The females immediately swam upstream, searching for cold gravel layers in which to dig their nests. The males launched themselves into brutal survival battles for the right to breed. Eggs were scattered across stones that had been left dry since the 1920s. When the survey period arrived, the measurements shattered every forecast. Between 200 and 400 juvenile salmon were found in every 100 square meters. In international biological records, even a river considered exceptionally healthy in Northern Europe usually sustains only about 50 to 100 fish per 100 square meters. This event demolished every mathematical model of ecosystem recovery speed. These fish had not merely survived. They had been storing strength for 100 years, waiting for the moment to release all that energy. The river was rushing to repay an entire stolen century. However, the rise of the salmon was only the first spark. Beneath the surface, a chain reaction was unfolding that was changing the entire biological structure. The intervention of dam removal released a complex symbiotic mechanism that had been frozen in place. Fast-moving water carried dissolved oxygen into the cracks between the stones, calling back millions of stonefly larvae and mayflies, the most critical food source for young fish. But the most remarkable biological event was the chance for the northern freshwater pearl mussel to return. The freshwater pearl mussel, a creature that functions like a biological filtration system and can live as long as 200 years, had reconnected with the most important link in its existence. A single adult mussel can filter dozens of liters of water every day, cleaning out bacteria and algae, but its life cycle depends 100% on salmon. When pearl mussel larvae are born, they must attach tightly to the gills of salmon, living as parasites and drawing nutrients for many months before dropping to the riverbed to develop into a hard shell. When the hydroelectric dam blocked the salmon, the pearl mussel population was also pushed to the edge of extinction. Now, as wild salmon carry millions of pearl mussel larvae freely throughout the watershed, ecological continuity is being restored. At the same time, the large-scale nutrient cycle has also been restarted. Salmon function as a giant natural nutrient transport system. They feed in the vast, deep lake, building up nitrogen, phosphorus, and biological carbon in their bodies. Ecological research from free-flowing rivers shows that as much as 80% of the nitrogen in riverside pine forests comes directly from the ocean or large lakes, transported entirely through the bodies of salmon. When they swim upstream to spawn and then die, their bodies decompose right in the river. That sudden abundance of food immediately triggers the rise of top predators. Otters, fish, eagles, and riverside mammals arrive to gather the carcasses, unintentionally spreading nutrients throughout the forests along the riverbanks. Natural fertilizer from the lake bottom is now being pumped straight into vegetation on land. An entire ecosystem has been re-energized again, all from one decision to tear out concrete. The ecological explosion at Hiitolanjoki has exposed a cruel reality on a continental scale. Right now, Europe's rivers are being severely fragmented by more than 1 million artificial barriers. Data published in the scientific journal Nature shows a barrier density of 0.74 structures for every kilometer of river. And it is not only Europe. In North America and many other regions, hundreds of thousands of weirs and barriers still remain like obsolete industrial ruins. They no longer serve the purpose of flood control or power generation, yet they still stand there as barriers choking the ecological arteries of nature. The World Fish Migration Foundation reports that migratory fish populations have collapsed by as much as 93% in just over half a century. Iconic species such as sturgeon, eel, and salmon are being erased completely from thousands of watersheds because of human planning mistakes. However, the trend of dam removal is now spreading across the world. Similar to the Hiitolanjoki project, the removal of 4 major hydroelectric dams on the Klamath River in the United States is reopening hundreds of miles of migratory route for salmon. In Spain and Sweden, authorities are also continuously removing artificial barriers that no longer hold any useful value. Scientists and policymakers are beginning to recognize one truth: the cost of maintaining abandoned dams is far greater than the cost of removing them and giving life back to the river. What happened at the Hiitolanjoki River shatters one of humanity's deepest assumptions. We always believe that once an ecosystem is destroyed, it is gone forever. We believe that artificial structures are permanent and that the collapse of nature is the inevitable price of progress. Reality has proven the opposite. The return of tens of thousands of salmon to an area that had once been nothing more than reservoir bottom mud has proven an ecological law that river did not die. It simply remained in a frozen state, waiting silently for the moment when the concrete cracked apart so it could reclaim what belonged to it. Sometimes, ecological recovery does not require advanced breeding technology or complex human intervention. The most effective solution is the removal of outdated physical barriers, allowing nature's own self-healing mechanisms to reactivate. This ecosystem was fortunate enough to survive until the final moment, but across the world, millions of other concrete barriers are still operating like ecological execution machines, counting down day by day. The biggest question now is this: are we ready to tear them down before the final chance disappears?